Hello, my name is Weiyou Cai. I'm presenting an always-on speech recognition using TrueNorth, which is a reconfigurable neurosynaptic processor. In the prototypical signal processing and classification flow, the inputs such as sounds, images, and events are processed to generate the classifications, reactions, or decisions. The intermediate function can be divided into two steps. The preprocessing step is typically programmed to perform specific functions to produce representations of the inputs. The classification step is automatically trained to produce outputs in a human-like way. The IBM TrueNorth chip is a good fit to perform this kind of flow. It not only has the innate support for trainable networks to perform the classifications, but also provides the explicit programming via spatial primitives for the preprocessing tasks. More importantly, it is reconfigurable. On one chip, there can be many flows for multiple applications. It also provides the fine-grained control of the synaptic cores and their connectivity. It is power efficient. A TrueNorth chip consumes 70 mW for 1 million neurons and 256 million synaptic connections. The traditional approach on the left uses the computation-intensive preprocessing function, male frequency capture coefficients, MFCC, to produce the high-precision features, and therefore consumes high power. The classification is performed by the energy-efficient deep neural network, EEDN, which is specified for TrueNorth, that can have the state-of-the-art accuracy. The proposed approach on the right uses the low-power audio transform on TrueNorth's ecosystem, Latte, to produce the approximated features to save power. We also propose the peripheral operations for spike-based representations so that all the preprocessing steps can be done on TrueNorth. As we can see from the comparison on the bottom, Latte produced different features to the MFCC, but they are still distinguishable among the different spoken digits. In this work, the preprocessing on TrueNorth with Latte has up to 32x active power savings, while the always-on system, combining the preprocessing and classification, consumes merely 14 mW, which is equivalent to a 450-hour battery life with a cell phone battery. For more information, please see our paper which covers these topics in greater depth. Thank you very much.